Good afternoon, everybody. I have one quick announcement before we get started today. I've got a graduate student who is looking for research assistants to help him with a study that he's running. This is probably going to be not for credit, at least for this semester, although if you wanted to next semester, we can get you credit. If you are interested in getting research experience, if you could email him and just mention that you're in my class and that I mentioned this to you, that would be great. His name is Kureva. You spell that Kureva. If you are interested in potentially joining his lab and doing some research with him, his email address is kmatu007@fiu.edu. So just to repeat that, his name is Kureva, that's Kureva. His email address is kmatu007@fiu.edu. All right, and with that out of the way, we are going to get started. I have to finish up the lecture I started last class. That's what I'm going to do now. Okay. So just to try to remind you of where we were last time, we were talking about the importance of social psychology being a science, being an empirical science, meaning relying on observation and experimentation as opposed to just arguing our way to the truth, which hopefully we established last class is a difficult thing to do. It's difficult to argue your way to the truth. There are very many plausible sounding arguments that are in fact completely erroneous, completely wrong. So we need to do something more than that. But why do we need to rely on experimentation? What if there are a couple other options of things that we can do? For instance, why can't we just watch people? Why can't we just observe how people behave and come up with our theories that way? Why do we need to create lab-based studies in order to study people? Or why can't we simply ask people how they behave in a given situation instead of running them through these complicated experiments that we have? And there's a number of reasons for this, for why we can't do these things. First off, we can't simply watch people and see how they behave because as experimenters, we have certain expectations for how we think people will behave. Maybe I have a theory of human behavior, and I expect that people in a given situation are going to behave a certain way. Well, we know that when people have expectations for how they think other people are going to behave, and when they observe those people behaving, that those expectations tend to bias their observations. And therefore, if I have one expectation and someone else, some other researcher has the opposite expectation, and we both observe the same behavior, we may come to different conclusions, different interpretations about that behavior, because our expectations have effectively biased us in our interpretation. And that's going to be a problem because for any science, we need agreement among researchers. Gravity works the same way, regardless of whether you're a physicist in North America or you're a physicist in Japan. It doesn't matter, right? Because gravity works independently of our expectations that we have. And the same thing needs to be true of any science, and especially of social psychology. We need to find truths that are consistent across different experimenters with different expectations. So that's one problem. A related problem is that we come from specific cultures, and the culture in which we're brought up can affect the way that we perceive things. And we're going to see this at some length later on in the course. We're going to differentiate between Western cultures, like the one we're in, and Eastern cultures, like Japan and China and Vietnam, etc. And we're going to see that there are fundamental differences in how people from those different cultures see the world. And those different cultural backgrounds that we bring to the table also affect the way that we interpret behavior. And again, if we need this to be a science, we need our findings to be independent of the researcher who's finding them. So that's a bit of a problem. We also bring certain values to the table. Maybe I have religious beliefs or moral beliefs or philosophical beliefs. I want certain things to be true as a consequence. And because I want them to be true, again, that can bias the way that I interpret behavior. And so again, we're seeing that different people who have different values might interpret the same behavior differently because of those differences in values. So these are all related ideas. And the basic general principle here is that our interpretation of an outcome or our interpretation of behavior is colored, is tainted, is biased by our view of the world, by our expectations, by our culture, by our values. So we need a way to study human behavior that doesn't fall prey to this biased interpretation of the world as much as possible. So that's why we can't simply watch people to see how they behave. What about if we asked people how they behave? Well, what we're going to see is that there are numerous ways in which the way in which we ask questions can change the answers that we get from people in a problematic way. We're going to see some examples of this. First off, we're going to see that how a question is worded can affect the way that people respond to that question. And so all the data I'm going to show you over the next few slides are data that were actually collected at various places around the US. And so I want to give you one example. So this is a question that was asked to some people. What is the most important problem facing our country today? Now, this was asked probably a couple of decades ago, okay, so it's not going to reflect the current situation. But when this was asked, people were given one of two sets of responses that they can choose from. So some people were given the following options. Is the biggest problem facing our country public schools? Is it abortion? Or is it something else? A second group of people were asked the exact same question, but were given a different set of response options. They were given the following response options. Is it public schools? Is it abortion? Is it healthcare? Is it drugs, violence, pollution, or something else? Now, of course, if you think, let's say, healthcare is the biggest problem facing our country today, and you're in this first condition and you weren't given explicitly healthcare as an option, you could always check off other, right? Well, let's see the responses that people gave. In this condition on the left, when you look at the responses that people gave, about 32% of people said public schools was the biggest problem facing our country today. But the problem is that when you look at people who are given the response options on the right, that number is drastically different. Now we're looking at only 4% of people who are claiming that public schools is the biggest problem facing our country today. So which is it? Is it 32% of people that think public schools is the biggest problem, or is it only 4% of people? Well, in fact, that question doesn't even really have an answer, because the percentage of people who are going to claim public schools as the biggest problem facing our country is in part determined by how many other options are in that list, in that response option list. Because imagine you're in this left side where you're given the options of public schools, abortion, or something else. And maybe you see the option public schools, and that triggers an idea, oh yeah, public schools are a problem. Maybe that is the biggest problem facing our country today. Now, had you seen the option of healthcare, maybe you would have realized, oh, healthcare is an even bigger problem. But you didn't see that option. And as a consequence, you said public schools. But if you're in the condition on the right, now healthcare is there, right? And so now maybe you're thinking, oh, healthcare, yeah, that's right. Healthcare is a big issue. And so instead of saying public schools, you're actually going to respond with healthcare. As a consequence, the total proportion of people who answer public schools goes down as you increase the number of options that are in that list. But this is a bit of a problem, because let's say that I'm trying to show that we need more money for public schools. So I want people to say that public schools is the biggest problem. Well, if that's the case, then I can ask the question, what's the most important problem facing our country today? And just give people two options, public schools, abortion, or something else. Then I'm going to get a high rate of people saying public schools because that stands out to them. On the other hand, if I'm someone who doesn't want funding for public schools, I want to cut funding for public schools, and I want to show that there are not many people in the country who think public schools are a problematic issue, then I can give them the response options on the right. And look, only 4% of people think public schools is the biggest problem. And so my values, my beliefs, etc., can creep into the number of response options that I give people, and can, as a consequence, change the way that people respond to this question. It's going to be a bit of a problem. But it's not just the number of response options that can affect people. There's other ways in which we might inadvertently bias the way that people respond to questions as well. So this was a question that was asked of people in Iowa. Some people were given the following statements. Helping farmers get a fair price for their crops should be the top priority of the Iowa legislature. Do you agree or do you disagree? And the number in brackets you're going to see is the percentage of people who said that they agreed with that statement. So in this case, 27% of people who were given the statement agreed with it. A different group of people were given the following statement. Education should be the top priority of the Iowa legislature. And now we see 86% of people agreeing with this statement. A third group of people were given the following statement. Crime should be the top priority of the Iowa legislature, and 34% of people agreed with that. Now, you should notice something somewhat problematic with these data, which is that if you add up these percentages, we get to 147% of people think one of these three things should be the top priority of the Iowa legislature. And this is a problem because obviously you can't have more than 100% of people claiming something as the top priority. So what's happening here? What happens is, again, when people see some sort of response, if they see that education should be the top priority of the legislature, then education is the thing that is salient to them. They're likely to agree with the thing that's salient to them because maybe they're not thinking about crime or helping farmers get a fair price for their crops. But if you give people another statement, crime should be the top priority, well, then that's the thing that's salient to them, and they're not thinking about education or helping farmers. As a consequence, again, if I was someone that wanted to show that people think that education should be the top priority of the legislature, then I can inadvertently bias my results by giving them only the second option, by giving people only the statement, education should be the top priority. And that's going to bias people to respond, to agree to that statement. So again, this is going to be a problem. Furthermore, the order in which you ask questions can also change the ways that people respond to them. So in this case, some people were given the following question first, or the following statement. The Japanese government should be allowed to set limits on how much American industry can sell in Japan. Do you agree or do you disagree? And then they were given statement B. The American government should be allowed to set limits on how much Japanese industry can sell in the US. Do you agree or disagree? So some people got A first and then B, and a different group of people got statement B first and then A. Now, if A is asked first, then few Americans agree with it. Not many people agree that the Japanese government should be allowed to set limits on how much American industry can sell in Japan. But if you first ask statement B, and you then ask statement A, if they agree with it, then now we find that over 2/3 of Americans agree with statement A. Now, why is that the case? Well, it's the case because if you get statement A first, an American thinks, you know what, the Japanese government shouldn't be allowed to set limits on American industry. I just don't think that's the case. But if you get statement B first, you start thinking the American government should be allowed to set limits on Japanese industry. Well, yeah, I agree with that. The American government should set limits. And then you get question A. The Japanese government should be allowed to set limits on how much American industry. Well, geez, I just agreed that the American government should be allowed to set limits. So to avoid being a hypocrite, I better agree with statement A. As a consequence, more people agree with statement A if they had already answered statement B. So this again is a problem. Or take the following situation. How many hours of TV do you watch per day on average? Now, this is a question with an objective answer, right? It's not just an opinion on something, it has an objective answer. And let's say that we give two groups of people the exact same number of response options. But for one half of the people, we give them the following options. Is it less than half an hour? Is it 1/2 hour to an hour to an hour and a half, an hour and a half to 2 hours, etc.? And the percentage on the right is the percentage of people who responded that they watched that many hours of TV per day. Now let's take a different group of people, ask them the exact same question, give them the exact same number of response options, except we're going to change the scale a little bit. So these people are given the following scale. Is it less than 2.5 hours? Is it 2.5 to 3, 3 to 3.5, etc.? And again, we see the percentage of people on the right who agree that they watch that many hours of TV per day. Well, there's something weird about these data. If we start off by looking at the right-hand side, if you look at all the people who claim to watch more than 2.5 hours of TV per day, you get a number of 37.5%. And yet, if you look for the people on the right-hand side who say they watch more than 2.5 hours of TV per day, you get a very different number. You get 16.2%, right? So what's happening here? Well, what happens here is this. Let's say that you watch about 3.5 hours of TV per day, right? And I give you the response options on the left. I give you that scale on the left, and you see that that scale tops out at 2.5 hours. And you start thinking, wow, I watch 3.5 hours TV per day, but the top of the scale is 2.5 hours. Wow, am I really that different from other people? Well, you know what? I have the TV on for 3.5 hours, but I'm only really watching it for an hour and a half per day. And so what happens is people adjust their estimates downwards because they feel more normal if they fit into the middle of the scale. On the other hand, if you're given the right options and you watch 3.5 hours of TV per day, well, that fits right in the middle of that scale, right? As a consequence, you don't feel a need to adjust those hours downwards. You're more likely to agree that you watch that many hours of TV per day. As a consequence, we get very different percentages of people claiming to watch, in this case, more than 2.5 hours of TV per day. So even the type of scale that you use to measure people's responses can drastically change the responses that they give. Or let's say you're asked the following question: do you support the murder of babies before they are born? Yes or no? And contrast that if you're instead given the following statement: do you support giving women the choice to remove fetal tissue from their own bodies? Now, both of these questions are effectively getting at the same idea. Do you support legalized abortion? Right? But the way in which you ask it is going to get people to respond very differently. No one wants to say they support murdering babies, but people are going to want to say they support giving women a choice to remove fetal tissue, right? So the way in which you frame that question can drastically change the responses that you get. And so if I am anti-abortion, I'm more likely to ask the first question. If I am pro-legalized abortion, I'm more likely to ask the second question. That's going to give me the responses that I want to get. So again, we're seeing that our values, our beliefs, our expectations can influence the way we ask questions and can influence the responses that we get to those questions. This is important because our theories about human behavior guide the policies that we enact. If we collect data that is incorrect, that is flawed or biased in some way, then the policies that are based on those theories are also going to be misguided. In fact, we saw this last class to some extent. We saw that in California, they instituted a policy back in the 90s to increase the self-esteem of all the kids in the state. And although there are some positive benefits to increasing self-esteem, there are also some negative problems associated with that. And we talked about how people who have unrealistically high self-esteem can behave like bullies. And so if our policies, such as raising the self-esteem of all the kids in the state, are based on an incorrect theory, which is that raising self-esteem can only lead to positive outcomes, then those policies are going to be misguided. We also saw this with respect to the DARE program, right, which teaches kids not to do drugs. The idea behind the DARE program is good. It's that we want kids, we want to teach them how to say no to people who are offering them drugs. But as I talked about last class, people who go through the DARE program are slightly more likely to try drugs than people who don't, according to some research. And that's because the program might be based on a faulty theory about human behavior, or at least an incomplete theory about human behavior. And so we really have to have accurate theories of human behavior if we want to develop policies that are going to achieve the aims that we want to achieve. So I'm talking a lot about the things that we don't want to do when we collect data, when we try to learn about human behavior. But really what I want to do is spend a little time talking about the things that we do want to do. In particular, what I want to focus on is the scientific method. And I want to lay out the basic underlying logic behind the scientific method. Because it turns out that the scientific method is the best process that humans have ever developed for finding out factual information about the world. And I want to take a look at why that's the case, the basics behind what the scientific method is, and why it tends to lead us to accurate findings. I think if you asked a lot of people about what the scientific method is, about what science is, I think a lot of people might respond by saying, well, science is a collection of all the things that we know. And it turns out that that idea of science is faulty. Science is much more than that. It's not just a collection of facts. And maybe Carl Sagan, famous astronomer, said it best: science is a way of thinking much more than it is a body of knowledge. Science has to do with the scientific process. It's a way of learning about the world that allows us to get accurate information about the world. And so I want to look at what that process is and why it tends to lead to accurate information if done correctly. I'm going to lay out a series of 6 steps. I'm going to gloss over a lot of the details here, and this is just kind of a basic idea of how the scientific method works. It's not quite as linear as this. It's not quite as stepwise as this. This is a little bit simplifying what the scientific method is, but this lays out in broad strokes the idea behind the scientific method. So the first step when applying the scientific method to a research question is that we need to define what the question is that we're studying. In other words, in social psychology, we don't just take a bunch of participants and throw them in a room together and just watch what they do. We have a research question in mind that we're trying to answer before we conduct any study. And we need to define what exactly that research question is. And let's just say for argument's sake, that this is the question that we have. Let's say we're interested in educational psychology, and we want to know, how can we improve children's performance in school? Now, it turns out that we need to define this question much more specifically than this. So for instance, when we say children's performance, what do we mean? Do we mean grades in class? Do we mean performance in standardized tests? Do we mean how much they've learned, how much they participate, et cetera, et cetera? But for now, let's forget that. Let's say that we've defined children's performance in terms of grades. Okay? So that's the question that we have. That's what we're going to work with. Well, once we have a question in mind, we don't simply rush into conducting that study. What we need to do is to collect background information, because scientific findings don't exist in a vacuum. They build off one another. And so if we want to answer a research question, we want to know what other research has been done on related topics. So we're going to go to the research literature, look at scientific journals, and we're going to learn about what's been done on these topics. So maybe when we do this background research, what we find is the following. We know that, let's say from other research, that people who are rewarded for a behavior, that increases the likelihood that they'll perform that behavior in the future. Okay, let's say we know that from other areas of psychology. And that is potentially relevant to our research question. Maybe we can use this information to answer our research question of how best to improve children's performance in school. So at this point, what we tend to do is to use a pre-existing theory to form a hypothesis. Now, a lot of people get confused between the difference between theory and hypothesis. We're going to talk a little bit more about what exactly a scientific theory is a little bit later. But for now, a theory is just a set of principles that allows us to make predictions. We'll come back to that. A hypothesis is a specific prediction that is based on a general theory. So let's say that our general theory, based on our background research, is that when you reward people, in general, when you reward people for a behavior, that makes them more likely to engage in that behavior. That's our general theory. And we can use that general theory to form a specific hypothesis related to our research question. Well, if it's the case that rewarding people for behavior makes them more likely to engage in it later, then maybe if we reward children with ice cream when they get a good grade, that will improve their grades on later tests. That hypothesis seems to be consistent with the theory that has been shown in past studies. So that's a reasonable hypothesis that addresses our research question, right? But we can't just leave it there. As I said, we can't just argue our way to the truth. We always have to test these ideas. So once we have formed this hypothesis, this prediction, then we're going to actually collect and analyze data to test that hypothesis. And we're going to spend some time today and some time on Thursday looking at a few different ways that social psychologists and psychologists in general have of collecting data, a few different types of research, of ways of collecting data. And of course, how to analyze data is something that you would talk about in a statistics class. I'm not going to talk about that here. But we need to collect data in a way that minimizes the extent to which our expectations and values bias our observations of behavior. But let's say that, for the sake of argument, this is our simplistic research design. Okay? What we're going to do is this. We're going to go into a school, and we're going to assign kids to one of two conditions. Some of these kids are going to get an ice cream reward every time they get a good grade. The other kids are not going to get an ice cream reward whenever they get a good grade. Then what we're going to do, we're going to take away that ice cream reward entirely. We're going to give all these kids one final test, and we're going to see how they perform on this test. Now note that if our hypothesis is correct, then the kids who had gotten ice cream before should do better on the test than kids who hadn't. On the other hand, if our hypothesis is wrong, we're not going to see that difference. So let's say we've collected these data, and let's say that we've analyzed them appropriately. Well, now we have to interpret these data. What do these data, what do these results mean in terms of our hypothesis? Do they support our hypothesis, or do we have to reject our hypothesis? So let's say, for instance, that children who got a reward for good grades earlier on actually perform worse on later tests than kids who never got ice cream to begin with. In fact, something like this is an actual social psychological finding, that rewarding people for a behavior can actually undermine their performance later on. That's an actual thing we're going to look at later on this semester. It's called the overjustification effect. We'll come back to that later on. The point is that right now, we've got to interpret these findings in light of our hypothesis. So does this support our hypothesis or not? Well, our hypothesis was that rewarding kids with ice cream would increase their performance. We find that it seems to be making their performance worse. So in fact, we have to reject our hypothesis. There's something wrong with our hypothesis. I do want to point out right here that we can support our hypothesis. If we had found that kids who got ice cream perform better on later tests, then we have supported our hypothesis. We have not proven our hypothesis. In fact, the word prove is something that exists in mathematics. It's something that exists in logic. It does not exist in science. We never prove something in science. We support our hypotheses. We can gain confidence that our hypotheses are correct, but we can never technically prove our hypotheses. And we're going to see why that's the case in just a minute. But for now, note that our results are inconsistent with our hypotheses. There's something wrong with our hypotheses. We don't just stop there, though. We have to try to figure out what is wrong. Why was our original prediction wrong in the first place? Well, our hypothesis was based on a theory, right? The theory said that if you reward people, they're more likely to engage in that behavior. So there's something wrong with that theory. Now, that doesn't mean we throw out the theory entirely. Usually when we find discrepancies between our findings and between our predictions, then usually that just means we have to tweak the theory somehow. We have to revise the theory somehow. So we go back to the original theory and we make a bit of an amendment to it. Maybe it's the case that rewarding people for behavior does improve performance, but only if you maintain that reward, only if you keep giving them ice cream. The moment you stop giving them that reward, the moment you take away, now all of a sudden their performance is harmed. So note that we're not throwing out the original theory. The original theory is still there mostly. We're just saying that rewarding people will improve their performance, but the exception is that if you take away that reward, now it's going to harm the performance. But we don't stop here either, because we don't know for sure if our new theory is correct. What we have to do is now test this new theory. So we go back to the earlier stages in the scientific method. We form a hypothesis based on this new theory. We test that hypothesis and we interpret our results to see if they support our hypothesis or not. Okay? So the scientific process is a mechanism whereby we're continually refining and adjusting and changing our theories based on our observations, with the idea being that by continually revising our theories, those theories get more and more and more accurate the more they're tested. And I want to talk a little bit more about what a theory is, because there's a lot of misunderstanding between the ways in which scientists use the word theory and the ways in which non-scientists use the word theory. So when you talk about theories with your friends, you might say, I have a theory about why this person did this. And what you really mean is you've got an educated guess, right? That is not how we use the word theory in science. And I want to talk a little bit more about that. So in order to understand human behavior, that requires us to use general principles of human behavior. If we conduct a study with 100 kids in the school looking at if ice cream improves their behavior, we're doing that not just to see whether these specific 100 kids can be affected by ice cream, but we want to be able to generalize that to other schools, to other kids, to other classrooms. We want to generalize our results from a specific sample to a population at large. In order to do that, we need to establish some general principles about, in this case, how people behave. And that's effectively what a theory is. A scientific theory is a framework, a conceptual framework that describes how variables are related to other variables. So in the theory that I just presented, we're describing how rewards are related to performance, for instance. Let me give you an example outside of psychology. I've got a pen here, and if I dropped this pen, every single one of you knows what's going to happen. It's going to fall, right? But how do you know that's going to happen? I mean, after all, you've never seen me drop a pen in this location ever before. So how do you know? How can you make a prediction that that pen is going to fall? Well, the only way that you can do that is because you have a theory at some level of how gravity works. You understand that when you drop something, they fall to the ground because of gravity. That's how gravity works. Right? It's your implicit theories of gravity that allow you to make those predictions. In the same way that in social psychology, it's our theories of human behavior and how people are influenced by other things that allows us to predict what's going to happen with other people. Okay? So a theory does not mean it's just a guess. It's a framework for understanding, for interpreting events. Why is it that pens fall to the ground? Well, because we have this theory of gravity that describes how things are pull on one another. Theory does not imply less than fact. One of the most common misconceptions people have is that in science, we start off with theories, and then once we prove them correct, they turn into facts. And that is not at all how theories work in science. It's why we still say we have a theory of gravity, even though we're very, very, very confident we understand gravity, at least at some level, right? It doesn't mean that we haven't proven it because, as I said, you never prove anything in science. You just get more and more confident that something's accurate, but you can never prove it with 100% confidence. So theory does not mean less than fact. But a lot of people misunderstand this. And so a number of years ago, some politicians wanted to put the following statement in biology textbooks for high school kids. They wanted to put this statement. This textbook discusses evolution, a controversial theory some scientists present as a scientific explanation for the origin of living things such as plants, animals, and humans. No one was present when life first appeared on Earth. Therefore, any statement about life's origins should be considered as theory, not fact. Okay, well, it turns out there's about 1 million things wrong with this statement. First off, evolution is not controversial among biologists in any way. It is not the scientific explanation for the origin of living things. It's the scientific explanation for the evolution of living things once they already exist. The fact that no one was present when life first appeared has nothing to do with how scientific something is. We understand how stars are formed, but no one was around a star when it was formed either. So that has nothing to do with anything. But really the point that I want to focus on is this last statement. Any statement about life's origins should be considered as theory, not fact. The belief that the politicians had who wrote the statement was that we have theories, which means we're guessing. And once we prove a theory correct, they graduate to fact. And because we haven't, we don't call it the fact of evolution, we call it the theory of evolution. Therefore, it's still in the guessing phase, right? That's not at all how scientific theories work. The theory of evolution means that we have an idea of how evolution works, which is a set of principles that describes how various things are related to one another. In other words, something can be both a theory and a fact. The theory of gravity is a scientific theory that describes how bodies of mass are related to one another, but it's also a fact that gravity exists. Okay. Theories, in a sense, are greater than facts. Theories explain why we observe facts. When I drop this pen and it falls to the ground, the explanation for why it falls to the ground is due to the theory of gravity. When I see planets revolving around the sun, the explanation for why they revolve around the sun is due to the theory of gravity. Theories explain facts. In the same way that in social psychology, social psychological theories explain facts about human behavior. Why do people behave in a certain way? Well, because of this general theory that we have that would explain it. Okay. Importantly, they describe relationships between things. I kind of mentioned that before, but they tend to describe relationships. So the theory of gravity describes the relationships between two bodies of mass, my pen and the earth, for instance, which is why it falls to the ground. Social psychological theories are going to describe relationships between, for instance, something in the situation, in the environment, and people's behavior. Okay? Importantly, theories allow us to predict what's going to happen. So if we go back to the scientific method, I mentioned that the hypotheses or the predictions that we have are based on underlying theories. in the same way that the theory of gravity allows me to predict that when I drop this pen, it's going to fall to the ground. This is important because in science, we almost always want to predict things that are going to happen in the future. And it's only with theories that we're really able to do so. That's why you're able to predict that this pen will fall to the ground, because you have a theory of how gravity works. So if we want to predict human behavior, which we do, if you remember from last class, one of the goals of social psychology is to predict behavior. If we want to be able to predict behavior, we need to understand theories of human behavior. One of the often overlooked points, I think, about theories is that they describe what variables are important and what variables are not important. So this pen is gray and gold, right? Well, what if I dropped a blue pen? What would happen then? Or what if there's a red pen or a green pen? Well, you know that it doesn't really matter what the color of the pen is. That has nothing to do with gravity, because in the theory of gravity, color doesn't play a role. So we know our theory of gravity says, the color of the objects does not matter. And as a consequence, we don't have to do a million studies looking at whether every different color pen falls in the same way. We know it doesn't because of the theory that we have. So it's describing what variables are not important. On the other hand, our theory of gravity says that certain variables are important. The mass of the objects, the distance between them, those are the variables that matter. Those are the variables that determine how quickly something falls due to gravity and things like that. There are some times where you've got some sort of observation in science, and there are multiple different theories that provide an explanation for the same finding. And under those conditions, we're often in a position where we have to choose between which theory better explains that fact. Now, ideally, what we would do is design an experiment that differentiates between those two theories. Sometimes, for various reasons, that's difficult to do. So we're left in a situation where we've got to choose which theory is better. Well, there are a number of criteria that make theories scientific, that make theories good theories. And I want to just quickly discuss what some of those are. First off, the more broadly applicable a theory is, the better it is, all else being equal. So maybe I have a theory of gravity that explains what happens in Minneapolis on Tuesday afternoons. But it's not a great theory because it's very limited in its scope. It only explains things that happen in Minneapolis on Tuesday afternoons, right? The actual theory of gravity that we do have, in fact, is very broadly applicable. It applies to what happens when I drop this pen, to the motion of galaxies throughout our universe. It applies to many, many things. The more things the theory applies to, the better it tends to be. A second criterion for what makes a good theory is that a good theory should be simple. And by simple, what I mean is that it shouldn't require us to assume much of anything. So for instance, let's say that I have a theory of dreaming. And my theory of dreaming is that when you fall asleep, these invisible elves come into your room and they open up your eyelids and they project movies into the back of your eyelids. And that's what dreaming is. You're seeing the projections of those movies that these invisible elves have. Now, that's clearly a bad scientific theory. But why is it a bad scientific theory? Well, it's bad because it's not a simple theory. It requires us to assume that invisible elves exist, right? Something for which we have absolutely no evidence whatsoever. So when a theory requires us to assume something that we have no evidence for, it tends to be a bad theory. So all else being equal, the simpler a theory is, meaning the fewer assumptions that go into that theory, the better it is. I alluded to this before as well, that a good theory is one that makes predictions for the future. It is possible to devise theories to explain past events that are unable to make future predictions. And those types of theories are not very good scientific theories. A theory is good to the extent that it's useful, that we can use it to do things. The theory of gravity allows us to predict what's going to happen to the planets and the moon and the sun and the galaxies years in advance, which could be important for launching space shuttles, for instance, to the moon. If a theory doesn't make predictions, it's not very useful. It doesn't really work as a scientific theory. And on a related note, a good scientific theory is one that is testable. Now, the idea here is that, as I mentioned before, a theory can never be proven correct. We never prove theories correct in science. It just does not happen. You can prove a theory incorrect, though. If my theory of gravity says this pen should fall to the ground, and I let go of this pen and it floats in the air, I have immediately disproved the theory. There's something wrong with the theory. Maybe it only requires a tweak or two, but there's something wrong with that theory. But if the pen falls to the ground, that's consistent with my theory, but it doesn't prove it because maybe tomorrow the pen's going to float in the air. Now, I doubt it. I'm pretty confident that's not going to happen, but I can never say I've proven that it will never happen. So what that means is that for a theory to get stronger, for us to get more confident that a theory is correct, it's not because we've proven it correct. It's because we keep trying to prove it false, and we keep failing to prove it false. When I drop this pen, if it drops to the ground, I haven't proven the theory correct, but I've been unable to prove it wrong. And so a theory gets stronger when you're increasingly unable to prove it wrong. And so what that means is that in order to fail to prove a theory wrong, you have to be able to test it. It has to be, in other words, falsifiable. There has to be some sort of observation that you could make that would prove your theory correct. If this pen hovers in midair, the theory of gravity would be proven wrong immediately. That would falsify it. Right? So there has to be some prediction it makes whereby if you observe one certain outcome, a pen floating in air, that would prove the theory wrong. Otherwise, the theory can never get stronger and stronger. It can never pass any tests. Right? The idea here is that in science, the theories that we have are approximations of truth. They may not be true with a capital T, but by continually revising our theories, by testing them, by being unable to prove them wrong, those theories get more and more and more accurate. They become closer and closer approximations to the truth, even though they may never reach the truth with a capital T. So let's take an example. Let's say that, and this is a tongue-in-cheek theory. No one really believes this, but as kind of a joke, someone had proposed this theory a while ago. The theory of the flying spaghetti monster. This is a theory that says that this flying spaghetti monster created the universe, the world, people, everything in it. Okay? He started off by creating trees and a mountain and a midget. And what happens is that when you die, you go to heaven. And in heaven, there's a beer volcano and a stripper factory and things of that nature. And this is the general theory for how the flying spaghetti monster works. Now, here's the thing, though, about this theory. So if you try to look for the flying spaghetti monster, he's invisible, so you'll never be able to see him. If you try to sense him in any way, he'll make it so that you cannot sense him. Every time you try to make a measurement to see if he's there, he's going to change your measurements to make it look like he's not there. Okay? And that's why we have, to this date, no evidence of a flying spaghetti monster, because he keeps changing our measurements to make it look like he's not there. And the question is this a good scientific theory? Now, clearly it's not, but the question is why? Well, let's assess this theory according to the 4 principles, the criteria that I just introduced to you. So first off, our first question is this theory broadly applicable? Well, in this case it is, because this theory applies to literally everything. The flying spaghetti monster created everything, so it explains every past event. So it is broadly applicable. However, is it simple? Well, it's most certainly not simple in this case, because to believe in this theory requires us to believe in the existence of a flying spaghetti monster, despite the fact that we have no evidence for it. We've never seen flying spaghetti and meatballs in the air. We've never seen any indication that this flying spaghetti monster exists. So we have to assume that it exists without any evidence. As a consequence, it's not a simple theory at all. It fails that criterion. Okay, well, does the theory make predictions? Well, not really. The theory claims to explain how the Earth was created, but it doesn't explain or doesn't make any predictions for the future as to how the Earth is going to evolve. What sort of test could we conduct to see if this theory is correct or not? If there's no test that we conduct, it doesn't make any predictions. It also means it fails the 4th criterion. It's not falsifiable. There is no observation that we could make that would falsify this theory. As a consequence, there's no way to test this theory, and there's no way for this theory to get stronger and stronger. So for those reasons, the theory of the flying spaghetti monster fails as a scientific theory, because it doesn't meet those criteria. Okay, let me pause here and see if anyone has any questions. And I'm sorry, I can't always keep track of the chat when I'm displaying my PowerPoint. So if you do have questions, it's often easier to ask me when I'm transitioning between PowerPoint slides. So if anyone has any questions about anything, I'd be happy to take them now. All good? Okay. Well, here's what we're going to do. I had asked you to get a Top Hat account for today. So we're going to test this out. I'm not going to actually give a quiz. So if you don't have a Top Hat account, you're not going to be penalized. But if you do have a Top Hat account, I want to make sure that everything's working properly. So if you have an account, I want you to log into Top Hat. You can either do this by going to the Top Hat website on your laptop or whatever and logging in that way. Or you can, if you've downloaded the Top Hat app onto your phone, you can open it that way. But either way, I want you to log into your account. We're going to make sure this is working for everybody. If you do not yet have a Top Hat account, make sure you get one. I can start giving quizzes as of next class, Thursday. So make sure that you go in by Thursday. Okay, so I'm going to give a couple test questions to make sure that you can all see the questions. So what happens is I've got questions that I've already written on Top Hat, but they're not available to you. But the moment I make them available, they should pop up on your computer screen or on your phone screen. You will then have, until I shut that question down, you have time to enter your answer. So we're going to try this. So the first question I have, I'm going to make available right now. So you should see a question pop up. Okay, and I see that people are starting to answer, so that's good. So you should see the question, how old are you, pop up, and there's 4 options. Just select the one, the option that you want, and there might be a submit button, and click the submit button. And you can see along the bottom, it says how many people have answered. There's 96 out of 103 people who are logged in have answered. And I'm going to close this in just a couple seconds. Oh, by the way, actually, before I do that, let me mention a couple ways to respond. There's another way to respond. Let's say your internet goes out, in which case I guess you wouldn't be listening to me. But if for whatever reason you can't respond via laptop or via cell phone, you can also text your response. So you should see a phone number, 315-636-0905. I suggest that everybody in the class enter that into their phone so that if everything goes awry, if you lose internet or whatever, right when I'm giving a quiz question, you can still text your response to that number. And what you would do is you would text the code. There's always going to be a code listed for each question. In this case, you should see 8352. That code is specific to this question. So that's telling Top Hat what question you're responding to. So you would text 8352 and then the letter of the response that you want to give. So if you're 19 years old, you type 8352B. It could be capital B, lowercase b, there could be a space before the B or not, doesn't matter. In order to respond by phone, you need to enter your cell phone number into the Top Hat system. Otherwise, Top Hat's going to get a text from a phone number it doesn't recognize. It's not going to know who to link it to. So the other thing you should do is in the Top Hat system, enter your cell phone number in there so that if you do need to use your phone, Top Hat knows who's doing it. Okay, and I should be able to close the question, and then I can see the responses, and you should be able to see these responses as well. Let me just see, because I've never done this over Zoom. Was everybody able to see, first off, the code that was associated with the question? Which gets a yes or no in the chat box. Okay. Okay, so here's what I'm going to do. Only a couple people said yes. I'm not sure why that's the case. What I'm going to do then, I think, is when I give Top Hat, I will share my screen with you. It appears on my screen, so if I'm sharing my screen, you should be able to see it. I'm going to try that for the next question. We're going to see if that works. Does that also mean that were you able to see the number of people who gave each response at the very end of that? No? Okay. All right, so what I'm going to do, I will share my screen when I do Top Hat then, in that case. So let's try another question. And I'll try to do this right now. Let's see if this works. Okay, so you should see my screen right now. So I'm going to go to test question 2. I'm going to present that. Okay, so you should be able to see my screen. And the question is, what is the capital of Canada? These are the Parliament buildings. They're in the capital of Canada. And you've got 4 options: Ottawa, Toronto, Montreal, or Vancouver. So if you were unable to see this before, then at the top, whoops, right here, in the top left-hand corner, that's the code that associates the question with your response. So you would text 1998. The number is always going to be the same, this phone number. You text 1998 and then A, B, C, or D to that phone number. Give people another couple seconds. Okay, let's close this. And now if I click responses, I can see how people responded. Most of you said Ottawa is the capital of Canada. That is correct. Ottawa is the capital of Canada. It is also the city where I was born and raised. It's Ottawa. Okay, so I think this is working. So let me try one more time. So when I shared my screen with you that time, were you able to see the code in the upper left-hand corner? Yes or no? Yes, perfect. And you were able to see how people responded to those 4 options? Yes or no? Perfect. Okay. So that's how we're going to do it, I think, then. Okay, let me get out of here. Okay, fantastic. So that's how we're going to take quizzes from now on. I'm just going to put them on top, and I'll share my screen with you. I'll always give you a countdown. I'll give you like a 10-second warning before I take the question off. You have to respond before I close the question. Okay, so make sure of that. Once I close the question, you're no longer able to respond at that point. But I'll always give you like a 10-second warning or a countdown or something so that you know when I'm about to close the question. Okay. Hopefully this will go off without a hitch. As I said, I've never done this over Zoom before, so I'm hoping this will work, but it seems to be okay as long as I share my screen with you. Okay. So, oh, you know what? I forgot to tell you guys. I should have told you this at the beginning. It turns out, um, uh, you're not going to believe me on this. It turns out that I'm psychic. I just found this out yesterday. It's a mind-blowing revelation. I am completely psychic. Um, and yet, when I look at your guys' face, you're not nearly as astounded as I expected you to be. I wonder why that is. You don't believe me? Okay, here's what I'm going to do. Here's what I'm going to do. I knew you weren't going to believe me. Okay, so I'm actually going to do a test. I'm going to prove to you that I'm psychic. Okay, here's what I'm going to do. I prepared for this. I have a pack of cards right here. Okay, just ordinary cards. I'm going to take the top 4 cards off the deck. Now, I've already prearranged these. The top 4 cards are all jacks. Well, not the ace. Let's get rid of the ace. Those top 4 cards are jacks. Hearts, spades, diamonds, clubs. Okay. Here's what I'm going to do. Keep your top hat open because what I'm going to have everyone do in the class, I'm going to have you pick a card, whichever one you want. And the card that gets the most responses, that's going to be the card the class picks. But I already know, as of right now, before you've even picked, I already know which card you want to pick as a class. You can try to fool me as much as you want. If you think that maybe the Jack of Clubs is the most commonly picked card, pick the Jack of Hearts. Pick some other card. Pick any card that you want, but I already know which card you're going to pick, okay? So let's put this to the test. So let me go back and into Top Hat. I've got a question already made for this, so let me share my screen with you. I'm going to open this up for 10 seconds or so. You're all going to pick a card. We're going to see the most commonly picked card. I already know what it is. Okay, so you should be able to see the question now. Hearts, clubs, spades, diamonds. Whichever one you want, you can pick. Okay, we've got about 3 seconds. I'm going to close it. And you should know there's no possible way I could possibly know what card people are going to pick, right? How could I possibly know? There's no possible way. And yet, I'm going to prove to you that I did know which card you're going to pick. So I'm going to close it right now. And I have not seen the responses. You're seeing what I'm seeing. So as soon as I click on responses, until then, I don't know what the card is. Once I click on that, I'm going to try to keep my hands in view so you can see I'm not doing anything weird. So I'm going to click responses now. Okay, and I got to move my screen here. Okay, so the card is what? Diamonds? 34 people picked the Jack of Diamonds. So the Jack of Diamonds is the card that you picked. But I tell you what, I already knew that was the card you're going to pick. Now, what I have to do, I have to get out of Top Hat. I've got to use my mouse. I'm going to grab my mouse. I'm just going to use it on here. So again, you see that I'm not doing anything weird. Let me end my Top Hat session. Okay. Hold on 1 second. Okay. I'm gonna have to move my hand for 1 second. I promise you, I'm not doing anything. I've actually written down this prediction. I just have to move my hand so I can get back into Zoom for 1 second, but I promise you I'm not doing anything weird. In fact, let me do this a little bit. So my hand's not writing anything. Where is my Zoom? Still not doing anything. Okay, here's what I'm gonna do. In fact, here's what's interesting. I've had this prediction in front of me the entire time, and I can prove it to you. I can move the screen down, and right in front of me is a piece of paper. And on this piece of paper, and there's only one piece of paper there, it's the only piece of paper. On this piece of paper is a prediction that I made prior to this class. Let me pick it up and show it to the screen. I knew you would pick the Jack of Diamonds. So do you believe me yet? Anyone want the lottery numbers? Still skeptical? I mean, it's right here the whole time. I could not have written this after I found out, right? I wrote this before. There's no one else in the room that put this piece of paper here. But you're still skeptical. No one's excited on this. Okay. What if I tried this again? Let's do this. I'm gonna have one person raise their hand, and that person can also pick one of the remaining cards. And I'm gonna show I also predicted this card as well. So who wants to raise their hand to pick a card? There we go. I got one. Okay. Is this Gwendolyn?
Hi.
All right. So you've got a choice of 3 other cards. So not diamonds, but one of the other 3 cards. Which one would you like?
Hearts.
You want the Jack of Hearts. Okay. This is my prediction, my first prediction, Jack of Diamonds, right? Again, I don't want to show, I'm not writing anything. Turns out I also knew you're going to pick the Jack of Hearts. I can prove this too. Remember that card pack I showed you at the beginning? In the back of that card pack is a piece of paper right there. Okay, it's the only piece of paper on the card pack. And if I take that piece of paper, open it up, and show it to you, I knew you'd pick the Jack of Hearts.
Oh, okay.
So, do you believe me yet? Still no? Does anyone know what's happening right now? So you don't believe I have ESP, it looks like. Just probably smart of you. Okay, well, let me give away the secret here. In case you are lost and not knowing what's going on, I imagine some of you know what's going on and some of you may not. Here's what happened. I actually had 4 predictions written down at various places around the room. And so I knew that if you had picked the Jack of Diamonds, I knew I had that prediction right in front of me. I can just angle my laptop down, I can show you that prediction. Had you instead picked the Jack of Hearts, I would have gone to the deck of cards and shown you the piece of paper in the back. Had you picked the Jack of Clubs, I would have shown you this piece of paper on the windowsill. that I could have grabbed to say, I knew you'd pick the Jack of clubs. And had you picked the Jack of spades, I would have flipped the cards around to show you that indeed I knew you'd pick the Jack of spades. Obviously, I don't have any psychic powers or ESP powers or anything of the sort. This is just a simple magic trick. But what is the point of this magic trick? Well, there's really kind of three main points that I want to make. Okay. Oops, I have not shared my screen. Okay, there's really three main points that I want to make. First off, as most of you rightly knew, evidence is required before you should believe a claim. And particularly, the greater the claim that is made, the greater the amount of evidence that you should require before you believe it. When I claimed I had psychic powers, at first I didn't give you any evidence whatsoever, right? And so you're rightly highly skeptical. And given that if I had psychic powers, that would be a really enormous claim, meaning it would contradict everything we know about physics in the natural world. That's a huge claim that should require a ton of evidence. And so you rightly didn't believe me. And even when I showed you that I had predicted it, that you'd pick the Jack of diamonds, of course you still didn't believe me because that's not sufficient evidence. So there's a sense in which you already knew that, right? That you need evidence before you believe the claim. But secondly, a second lesson to take away from this is just because you can't figure out an alternative explanation from the one that I gave you doesn't mean that you have to accept the one that I give you. Even if you didn't know how I predicted that you would pick the Jack of diamonds, doesn't mean you have to believe that I have psychic powers. And this is important because there are people who will lie to you and will tell you something that they want you to believe. And if you can't understand that thing, if you have no explanation for how they did something, they will tell you you have to accept their explanation. People do this all the time. There are people who claim that they can talk to dead people, and they will put on a show where it makes it look like they know information that they don't actually know, and they tell you that's because they're talking to your dead relatives. Well, it turns out that people who do this are using simple techniques that magicians have known for decades and decades. In fact, you can research these techniques if you want by looking up hot reading or cold reading, or cold reading is the main one of these. But it doesn't mean, just because you don't understand how they do that cold reading, doesn't mean you have to accept their claim that they are actually talking to the dead. You should be skeptical of claims, especially claims that violate what we know about the universe, right? But maybe the most important lesson, the one that's most relevant for the rest of today and Thursday's class, is the third lesson, which is that the strength of a conclusion that you can reach is directly related to the amount of control that you have over the situation. So for instance, in this situation, I controlled the test. I had the cards. I controlled where the predictions were. I controlled what qualified as a success or a failure. You had virtually no control. Because you had so little control, it's really hard to reach strong conclusions. In other words, you can't really believe that I have psychic powers, even if I showed you, supposedly, that I predicted which card that you would pick. On the other hand, if I claim to have psychic powers and you provided the test and you controlled the situation in such a way that I couldn't cheat, and I still seem to be able to predict what card that you picked, now maybe you can start to believe the claim, right? The conclusions that you can draw are directly proportional to the amount of control you have over the situation. And just like that's the case in that little demonstration, it's also the case with research methodology, that when you conduct different types of studies, those different studies have different amounts of control that you might have over them. And the more control that you as a researcher have over the situation, the stronger are the conclusions you can draw from your results. And that theme is going to underlie the rest of this lecture going through Thursday. Now, what I'm going to do is I'm going to introduce you to three types of research on Thursday. And you're going to see those different types of research vary in terms of the amount of control the researcher has over the situation, as well as the strength of the conclusions that you can draw as a consequence from your results. But before we get there, I first want to ask the following question. When we run a study, we don't run a study on everybody. If I have a study about human behavior that I think applies to 7 billion people on this planet, I don't run 7 billion people through my study. I select a sample of people to run through my study. And the question is, how do we select that sample of participants that we're going to conduct the study on? Well, to answer this question, the first thing we need to do is to identify a population. A population is the group of people that we think our findings apply to. So if I have a theory about human behavior that I think applies to all humans, then my population is every human on the planet. If my theory only applies to FIU undergraduate students, then my population is FIU undergraduate students. So we need to figure out who are we applying this theory to, and that way we can identify a population of people. That's the first step. Sometimes, though, the population is not always easy to define. It can be difficult to define. So let's say that we want to predict who's going to win the upcoming election in 2 months. So we're going to sample. We can't obviously ask all 330 plus million people in the country, right? So we're going to select a sample of people. So to do that, we have to identify the population. Who's the population we want to generalize our results to? Well, immediately it might seem that we want to generalize our results to everybody in the US. We want to reflect the opinions of everyone in the US, right? But after a little bit of thought, we realized that can't be the case because not everyone in the US is even eligible to vote. Children can't vote. It doesn't matter what children, who they prefer in the upcoming election. So we don't want to generalize to children's opinions. So it can't be everyone in the US. So maybe it's adults in the US. Adults can vote, right? Well, not always. Convicted felons aren't able to vote. Or maybe there are many, many adults who don't vote in the election. And if they don't vote, that's not going to help us predict. We need to know what the voters, who they're going to elect. That's what we're trying to predict, right? So our population isn't just adults. We want to generalize to a smaller population than that. So maybe the population is eligible voters. Eligible voters are able to vote. So that would exclude convicted felons, for instance. But eligible voters aren't really who we want to generalize our results to, because not every eligible voter votes. Only a subsection of eligible voters vote. And those are the people who we really care about. So maybe we want to say, well, who are the likely voters? Who are the people who are likely to vote in the next election? Well, it's a difficult question. How do we know if someone's likely to vote in the next election? Well, maybe we could say, well, people who voted in the last election are likely to also vote in this election. But that can't really be our population either, because there are some people who were ineligible to vote last election. They weren't old enough to, but they're old enough to now. There are some people who voted in the last election that won't vote in this election for various reasons. And so we can see that defining exactly what this population is that we're trying to generalize our results to can be a little bit tricky at times. But let's say that for the sake of argument, that we've done this. We've defined our population. Well, once we've defined our population, if we want to generalize from our sample to our population at large, the only way to do this technically is with a process known as random sampling. In random sampling, what we do is we ensure that every person in the population has an equal chance of being in our sample. So let's say that in a normal school semester, school year, let's say I was teaching in a lecture hall, right? And I had a theory that I think applies to every student in the class. Well, what I wouldn't do, if I was going to run a study on a sample of 20 students in the class, I wouldn't just take the 20 people in the front 2 rows. That's not a random sample. Everyone in the population doesn't have an equal chance of being in my study. If you're in the first 2 rows, you're 100% going to be in my study. If you're in any other row, you have 0% of being in the study. The problem is that if I don't randomly sample, then the people I'm choosing, so the people in the front 2 rows, they may be different than people in all the other rows in the class. They might be different than the rest of the population. Maybe people in the first 2 rows have worse eyesight, which is why they sit in the first 2 rows. Or maybe they're more motivated to get a good grade, which is why they're sitting right up front to make sure they don't miss anything. The point being is that any non-random sample does not necessarily, we can't guarantee it reflects the population at large. And so therefore, we can't generalize from them to the population at large. The only way to generalize is to take a random sample, whereby everybody has an equal chance of being in our sample. That ensures, statistically, that our sample reflects the larger population. That's representative of the larger population. And so if we want to predict who's going to win in the next election, the best way to do this is to get a random sample of all people who are going to vote in the next election. Now, that's a very difficult thing to do. Random sampling is an ideal. We strive to randomly sample, but in reality, it never actually happens because it's just way too difficult. If our theories of human behavior apply to everybody on the planet, how can you randomly sample from everybody on the planet? It's just impossible, right? If our theories apply to everybody in the US, how do we randomly sample everybody in the US? It's impossible. So what researchers do is they tend to rely on what are known as convenience samples, which oftentimes means you guys, college students. You guys are very convenient to sample because you want extra credit in classes, and we give you extra credit if you participate in our studies. Now, that being said, you guys aren't reflective of the general population. You're college students, first off. Most people don't have a college degree, so you're probably a little bit more intelligent than the average person. The demographics at FIU are going to be different than the demographics of the country at large. There's many ways in which you differ from the population, and as a consequence, it gets tricky to generalize from these samples to the larger population. So researchers have to be very sure, or I guess we should say, have to be very cautious when trying to generalize from these convenience samples to the larger population. And it's this logic that underlies the idea of juries. So if you think of a jury, you're supposed to be tried by a jury of your peers, right? By your peers means if you are arrested in Miami, then a jury of your peers would be other people from the Miami area. Now, if juries were selected by, let's say, just having people volunteer to be on the jury, right? Well, then that jury, that sample of 12 people that sit in the jury, is not necessarily going to be reflective of the larger population because it wasn't randomly sampled. Maybe people who want to sit on a jury differ from other people in various respects. Maybe they're more likely to vote guilty, for instance, if you want to sit on a jury because you want to see justice done. As a consequence, that's not really a jury of your peers. So what we tend to do is we try to randomly sample from the population to pick our jury. This is why you might get a jury summons in the mail that says you've been randomly selected to sit on a jury, because that's a way to try as much as possible to select a random selection of people from the population to sit on the jury. That's the basic idea. Okay. I'm going to stop things here. I realized that last class I forgot to wait around if people had any questions, so I'm going to do that now. And so if you have any questions or issues that you want to talk with me about, then hang on for about 1 minute. If you don't have issues, you can leave, I guess, at any time. Remember, if you don't have a Top Hat account, make sure to get one for Thursday. So if you need to leave, then I will see you on Thursday. If you want to stay around because you have questions or comments, hang out for a minute, and then I will start some one-on-one conversations with you. Okay? Thanks, everybody.